discussion regarding hydraulic conductivity. So we will be having more sample problems. So we have here the void ratio and hydraulic conductivity relation for a normally consolidated clay are given below. Meron tayong values of void ratio and their corresponding hydraulic conductivity in centimeter per seconds. Nako, wait lang. Iba yung na-present ko. Oops. Okay, again, good morning po. Let's continue the discussion regarding hydraulic conductivity. So we have here the void ratio and hydraulic conductivity relation for a normally consolidated clay are given below. And we are required to find the hydraulic conductivity when the void ratio of the soil becomes 1.8. So meron tayong binigay dito na void ratio and their corresponding hydraulic conductivity. Ngayon, kapag yung void ratio daw ay naging 1.8, ano yung corresponding hydraulic conductivity niya? Sabi ko last time, hydraulic conductivity is directly proportional to the void ratio. Na kapag tumataas yung void ratio natin, dapat tumataas din yung hydraulic conductivity. No? So dito, mapapansin nyo, tumataas. No? Yung trend ng ating values of void ratio. So dapat, ang ating clue, yung ating makukompute na hydraulic conductivity should be greater than 1.519 times 10 raised to negative 7 per centimeter per seconds. No? Eh, anong gagamitin nating equation to solve this problem? Sabi doon, computation of hydraulic conductivity for a normally consolidated clay. And iisa lang po yung present nating equation on how to compute the hydraulic conductivity for a normally consolidated clay regarding empirical relations. No? And that is Samara-Singhe equation. So dapat ma-analyze nyo na yun dapat yung gagamitin nating equation. Ano ba yung Samara-Singhe equation? That is hydraulic conductivity equivalent to C multiplied by E raised to N over 1 plus E. That variable C and variable N are constant variables. Ibig sabihin, kapag nagbabago yung hydraulic conductivity at yung void ratio, hindi nagbabago yung constant C and N natin. Ibig sabihin, kung ano yung constant C sa first set of values, yun din yung constant C sa second set of values tsaka third set of values natin. Same with the value of N. Pare-parehas yan. No? And with that, We can say that constant C of first set of values is equivalent to constant C of the second set of values. What is the value or formula for constant C? Using summarizing equation, by simplifying that, cross-multiply lang natin, C will be equivalent to K multiplied by 1 plus E over E raised to N. So substitute lang natin dito sa equation natin. And that will become K multiplied by 1 plus E over E raised to N ng first set of values. Equivalent to K multiplied by 1 plus E over A raised to N ng second set of values natin. No? So we can now compute the value of variable n in this equation. No? Substitute lang natin mga binigay na parameters. What is hydraulic conductivity dun sa una? That is 0.6 times 10 raised to negative 7 centimeter per seconds. Multiplied by 1 plus void ratio ng first set of values natin, 1.2 over 1.2 raised to n. Equivalent to, substitute naman natin yung parameters sa second set of values natin. Hydraulic conductivity is 1.519 times 10 raised to negative 7 multiplied by 1 plus 1.52 over 1.52 raised to n. Iisa lang yung unknown variable natin dyan, which is n. So you can simplify this equation or pupad nyo ng input sa calculus and then shift solve natin. No, canceled na yung times 10 raised to negative 7. Ito, centimeter per seconds din yan. Canceled na yung unit. So, compute variable n. Ano po yung value niya?
$4.50 po.
4.50. How about the others? Kindly confirm.
Same lang po.
Okay,
Same lang
store
po.
natin yung value as A para hindi tayo nag-round off. No? Kapag na-compute nyo na yung variable n, you can now compute variable C using equation of C1 or equation of C2. No? Kahit anong gamitin mo, parehas lang yon dahil in-equate natin yung dalawa. Therefore, variable C is equivalent to K multiplied by 1 plus E over E raised to N. Gagamitin lang natin itong unang set of values natin. No? And that is 0.6 times 10 raised to negative 7 centimeter per seconds multiplied by 1 plus 1.2 over 1.2 raised to n, which is 4.50. Naka-stored value po dapat. Ano po ang ating variable C?
5.81 times 10 raised to negative 8.
Okay, that is in centimeter per seconds. No? How about the others? Parehas po ba?
Same lang po, sir.
Okay, store natin yung value as B. Now, ang pinapa-compute hydraulic conductivity at a void ratio of 1.8. Meron ka ng constant C, constant N. Meron tayong void ratio, you can now compute hydraulic conductivity. No? Substitution na lang yung mangyayari doon. Therefore, at a void ratio of 1.8, hydraulic conductivity is equivalent to C, naka-stored value yan, 5.81 times 10 raised to negative 7 or negative 8 centimeter per seconds multiplied by void ratio 1.8 raised to n 4.50. Naka-stored value din over 1 plus 1.8. Ano po yung hydraulic conductivity natin? Again, ang hint natin, it should be greater than this value. No? Pag mas mababa doon, may mali sa computation. Ano po yung na-compute?
2.93 times 10 raised to negative 7.
Okay, and that is greater than 1.519, di ba? So that is centimeter per seconds also. And that will be the requirement of this problem. No? Same answers po ba dun sa iba?
Yes
Yes
po,
po,
sir.
sir.
Po, sir.
Okay. So, yan yung solution natin, no? For this problem. Let's have another one. We have here the results of a sheave analysis for a sand is given below. We have to estimate the hydraulic conductivity using Carrier equation. Given the void ratio of the sand is 0.6 and shape factor or SF is equivalent to 7. And then meron tayong binigay dito, results of a sheave analysis or mechanical analysis or particle size distribution. No? Ngayon, may binanggit na gagamiting equation. Pero, kahit na hindi binanggit na carrier equation, dapat ma-analyze nyo na carrier equation lang yung pwede nyong gamitin for this type of problem. No? Dahil yung carrier equation lang ang may parameters wherein gagamitin natin yung result ng sheave analysis natin. No? Ano ba yung carrier equation natin? Hydraulic conductivity is equivalent to 1.99 times 10 raised to 4 multiplied by the quantity 100% over summation of Fi over DLI raised to 0.404 times DSI raised to 0.595 quantity squared multiplied by 1 over SF quantity squared multiplied by E cube over 1 plus E. There is a correction, ha? Last time, ang panisan ko ay SS. It should be SF, no? So, ito yung equation ng carrier equation. Ngayon, we have now SF. We have now E in this given problem. Ang kailangan natin i-simplify ay itong parameter na to, no, para ma-compute yung hydraulic conductivity. Ngayon, ano ba yung 100% divided by summation of Fi over DLI raised to 0.404 times DSI raised to 0.595. That is what we call effective grain size of the solid grains. No, that is D10. No? Ngayon, anong kailangan natin kay effective grain size? We have here Fi. Ano ba yung Fi? That is fraction of particles between two consecutive sheave. No? Yung Fi daw ay yung difference ng percent passing ng dalawang magkasunod na sheave. So, nandito yung Fi natin. Meron tayong 5 sheave na ginamit. Yung number 30 tsaka number 40 magkasunod. 40 and 60, 60 and 100, 100 and 200 magkakasunod yan. No? Between 30 and 40, ang passing percentages nila ay 196%. So what is Fi? Yung difference ng dalawang yan. That is 4%. Between 40 and 60, ito yung passing percent nila. Iko-compute lang natin difference to compute Fi. That is 12%. Dito naman, 34%. And then 50 minus 0 is 50. No? Ngayon, meron tayong Fi. Meron tayong parameter also dito na DLI tsaka DSI. When we say DLI, diameter or opening of larger sheave. Yung DSI, diameter or opening of smaller sheave. No? So, kailangan natin ng openings. So, dapat familiar pa rin kayo sa openings ng bawat sheave numbers na to. No? Meron tayong mga binigay dyan in millimeters. Ang number 30, merong opening na 0.6. Ang number 40, may opening na 0.425. Number 60 is 0.25. Number 100 is 0.15. Number 200 is 0.075 in millimeters. But, kapag isusubstitute daw natin yung DLI tsaka DSI, it should be in centimeters. Para automatic naka-centimeter per seconds yung hydraulic conductivity. So, itong millimeter opening na to, ika-convert natin into centimeters. No? So, alam nyo na yung conversion. Divide nyo lang by 10, magiging centimeter na yan. This will become 0.06. Ito 0.0425. Ito magiging 0.025. 0.015 and 0.0075. So ito na yung gagamitin natin na openings, naka-centimeters. So, analyze first effective grain size. That is 100% divided by summation. So madami tayong isa-sum up. No? Simplify muna natin yung unang magkasunod na to, sheave. Number 30 and number 40. Kukunin natin yung Fi over DLI times DSI nila. Between number 30 and 40, ang fraction of particles nila ay 4%. Over, ano ang DLI? Between 30 and 40, ano ba yung mas larger opening dyan? Yung 0.06, di ba? So that is 0.06 raised to 0.404 times DSI yung smaller sa dalawang yan, which is 0.0425 raised to 0.595 plus, susunod naman natin yung 40 and 60 sheave. Ang Fi nila ay 12%. Divided by DLI, ang mas larger kay 40 tsaka 60 ay yung 0.0425 raised to 0.404 times ang smaller sa kanila ay 0.025 raised to 0.595. And then, plus ulit, susunod nating number 60 and number 100 na sheave. And their fraction difference is 34%. No, that is 34% divided by DLI 0.025 raised to 0.404. Ang DSI ay 0.015 raised to 0.595. Plus, the last one, number 100 and number 200. Ang kanilang Fi ay 50%. DLI ay 0.015 raised to 0.404 times DSI 0.0075 raised to 0.595. No? So with that, we can now get the value of effective grain size of the solid grains. Kindly compute. Medyo mahaba lang yan. Simplify nyo lang isa-isa. Baka hindi kasya sa calculator.
$7,515.06.
Parang mali. How about the others? Take note, effective grain size, guys. When we say effective grain size, diameter of particles corresponding to 10% passing. Tingnan nyo yung data natin. 50% to, 0% to. So yung 10% nasa pagitan ng 50 tsaka 0. So dapat nasa pagitan ng 0.015 tsaka 0.0075 yung makocompute nating sagot.
0.013 po.
0.013
3.
and then
307.
parang mali yun.
Zero 0.0138.
138 yung isa. How about the others? 138 or 137?
0.01378022694.
How about the others? Parehas po ba? Kindly confirm.
$0.0138 po.
Parehas lang, 0.0138. Yung iba, parehas lang. Paki-confirm po.
Same po sa akin, sir.
Okay. Store natin kay A para hindi tayo nag-round off. No. That value is between 0.015 tsaka 0.0075 kaya okay siya. No. And then, kapag na-compute mo na yan, makakompute na natin yung hydraulic conductivity. No. Therefore, substitute lang natin sa equation ni Carrier. That is equivalent to 1.99 times 10 raised to 4 multiplied by 0.0138 quantity squared multiplied by 1 over shape factor of 7 quantity squared multiplied by E cubed. Ang void ratio natin ay 0.6 over 1 plus E, which is 0.6 ulit. So, what is hydraulic conductivity? 0.04.
0.0104.
Parang may discrepancy yung nako-compute yung sagot. No? I think it should be 0.0137 here. 1367, if I'm not mistaken.
0.0136655 po.
0.0137 yan, tama?
Apo.
Yes po.
How about the others?
Ganun po ang nakukuha.
0137 din.
Opo.
No, pag may discrepancy kasi, medyo magkakaroon din tayong discrepancy dito. 0.0102 dapat to. And that is in centimeter per seconds. No? And that will be the requirement of this problem. No? Litan nyo lang yun. Okay. So, kindly check your answers, no? Dahil kapag sinabi nating 4 decimal places, medyo mamamali na tayo. Diba? And do not round off in between your solutions. Okay, so that will be the requirement of this problem. No? So, let's have another one. We have here, for a constant head permeability test in a sand, the following values are given. We have L, or the length of flow, 350 millimeters. A, or cross-sectional area, 125 square centimeters. H, the constant head difference, 420 millimeters. We have the water collected in a duration or time of 3 minutes is equivalent to 580 cubic centimeters, and that is a volume parameter. The void ratio of sand is 0.61. We have to determine the hydraulic conductivity, K, in centimeter per seconds. Also, the seepage velocity. So, nabanggit na yung constant head permeability test. Dapat alam niyo yung equation yan. That hydraulic conductivity is equivalent to QL over AHT. No? So, we have now the volume, 580 cubic centimeters. The length of flow is 350 millimeters. Over cross-sectional area, binigay na din. Constant head difference, binigay na din. Duration, binigay na din, 3 minutes. Now, analyze the units. Millimeters, cancelled. Cubic cm, divided by square cm, cm na lang natira, di ba? Tirang isang cm, centimeter per minute tayo. Eh, ang kailangan natin, it should be in centimeter per seconds. So, conversion of units lang. That is 1 minute is to 60 seconds. So, what is hydraulic conductivity?
0.0215.
0.215 centimeter per seconds. Kindly confirm.
Same lang po.
Same lang po.
Same po. Same.
Okay, so that is stored at A. Now, compute seepage velocity. Sabi natin, ang seepage velocity is the ratio of discharge velocity and with respect to porosity. But according to Darcy's law, discharge velocity is the product of hydraulic conductivity and hydraulic gradient. Hydraulic conductivity na solve na natin. Hydraulic gradient, wala pa. But it is the ratio of the head loss with respect to the length. No, over porosity. Wala pa tayong porosity. Ang binigay ay yung void ratio. Pero ang porosity may relationship kay void ratio, which is E over 1 plus E. So direct substitution na tayo, di ba? Hydraulic conductivity is 0.0215 centimeter per seconds. Head loss is 420 mm and the length is 350. Void ratio is 0.61. So this is 420 millimeters divided by 350 millimeters over void ratio of 0.61 divided by 1 plus 0.61. What is seepage velocity?
Zero 0.068.
Centimeter per seconds. How about the others?
Same lang po, sir.
Okay, so that will be the requirement of this problem. No? Medyo mahirapan lang kayo sa units. No? So isipin nyo, for an examination, paano papahirapan ni sir yung problem na to? No? Paano magiging tricky? Paano hihirap? No? Pwede na po magbigay ng ganun. Pero isipin nyo kung ano yung posibleng maibigay sa exam. Next one. Two cylindrical soil specimen A and B are subjected to a modified constant head test as shown in the figure below, where the two specimens are tested simultaneously. The diameter of the specimens is 75 millimeters. Parehas daw yung diameter. And as you can see, parehas dapat. In 10 minutes, 650 grams of water is collected in a bucket. Determine the hydraulic conductivity of the two soil specimens. Ano yung hydraulic conductivity ni soil A? Ano yung hydraulic conductivity ni soil B? No? Ngayon, ating setup. Nandito yung inflow sa taas, nandito yung outflow. No? So malalaman nyo na kung anong kind of flow yan. No? So, ang binanggit doon, constant head test. Again, this same equation, that hydraulic conductivity is equivalent to QL over AHT. Yung hydraulic conductivity for soil A muna yung isusolve natin. Do we have volume of water kay soil A? Wala pa. No? Ngayon, kung ano yung volume of water na nag-flow kay soil A, yun din yung volume of water na nag-flow kay soil B. At yun din mismo yung na-collect natin dito. Tama. Ang binigay, mass of water, 650 grams. Kailangan natin volume of water. So, to compute that, we are using density of water, which is the ratio of mass of water with respect to the volume of water. Ano ang density ng water? 1 gram per cubic centimeter. Ano ang mass of water? 650 grams. Divided by VW, cancelled yung grams. Therefore, we can say that VW is 650 cubic centimeter. And that is the value of variable Q. No? So, ito magiging 650 cubic centimeters. Multiplied by L, which is the length of the flow. Ano sabi natin kay length of flow? It should be parallel to the direction of the flow. Paano ba mag-flow? From this point, mababa, and then papasok siya ng ganyan kay soil A. So ano yung distance kay soil A na parallel sa direction na to? That is 350 mm, di ba? No, yung 350 mm kay B, yun din yung length of flow dahil parallel yan sa direction ng flow natin. So, multiply it by 350 millimeters, divided by cross-sectional area of the soil. Yung cross-sectional area, it should be perpendicular to this direction of flow. No? Ito yon, linya lang yung nakikita natin dyan. Ano bang binigay? We have the diameter of the soil. No? So ito, diameter yan. That is 75 millimeters. Gagawin lang natin siyang centimeter para maging consistent yung units. And the same yung diameter ni soil A and soil B according to this setup. No? So, substituting, pag may diameter tayo, therefore, circular yung cross-section. No? And then H, the constant head difference or the head loss. Head loss ng soil A. Para ma-analyze natin yung head losses ng bawat soil, titingnan natin mismo yung mga pipes or piezometer na nakadikit or nakakabit sa magkabilang dulo ng mga soil. Ito yung dulo ng soil A. Ito yung isang dulo. Ito yung pipe na nakakabit doon. Ito naman yung pipe na nakakabit sa isang dulo. And then, titingnan natin yung energy head sa mga piezometers na yan. Merong difference sa energy head. Tama? So, yung difference na yun yung head losses natin. And that is the head loss of soil A. Kasi nga, kinonsider lang natin dulo-dulo ng soil natin. For soil B, ito yung head losses niya. Or head loss niya. Dahil ito yung i-consider mong piezometer, which is attached at the ends of this soil B. Paano naman kapag kinonsider natin tong point na to, and then tong point na to? Yung dulo ng soil A, tsaka yung dulo ng soil B. No, that will be the total head loss of the setup, which is the summation of the head losses of the layers involved in this flow. No? Pero hindi pa naman natin kailangan yon. So, head loss of soil A is 200 millimeters. Multiplied by the duration, sabi doon, in a time of 10 minutes. So, wala naman tayo ni-require na unit for hydraulic conductivity. Ito, cancelled. Ito, magiging centimeter per minute tayo. What is hydraulic conductivity of soil A?
.257.
Parang mali. Parehas pa sa iba? Tama?
Mali po pala, sir.
Or 2 point something?
2.57.
2.57.
Centimeter per minute. No? Store natin kay A. Now, compute the hydraulic conductivity of soil B. Same formula. Kasi nga, it was tested simultaneously. So, gagamitin natin parehas yung formula ni constant head test. For soil B, ano yung volume? Sabi natin parehas lang yung nagfo-flow sa kanila. For soil B, ano yung length? 350. For soil B, ano yung cross-sectional area? Parehas pa din. No. For soil B, ang ating head loss ay 150 millimeters. So, yun lang yung nagkaiba. No. Yung duration, parehas pa din. Diba? Dahil it was tested simultaneously. Sabay sila mag-i-start, sabay sila matatapos. So, 10 minutes also. No? So, now compute hydraulic conductivity of soil B. Again, that is also in centimeter per minute.
3.43.
3.43 centimeter per minute. No? Store natin kay B. Although these are the requirements. No? Yan yung sagot natin. Paano kapag sa problem na to, pinapakuha yung total hydraulic conductivity or yung equivalent hydraulic conductivity? Pag sinabing equivalent, dalawang condition. No, depende sa kind of flow. Horizontal ba yan or vertical? Ano ang sabi natin kay horizontal? The water will enter the layers of soil at the same time. Sabay-sabay. Sabay-sabay ba pumasok yung tubig sa soil A at soil B? Hindi. Diba? Yung tubig from this point sa taas, papasok muna kay soil A and then lalabas siya doon, saka papasok kay B. And then lalabas, nandito yung outflow. So, it will flow in the layers of soil one at a time. So, that is a vertical flow. Kung vertical flow yan, kung pinapakompute yung equivalent or total, dapat yung KVEQ yung gagamitin natin. No, regarding vertical flow. Ano yung formula niyan? That is total H over HA over KA plus HB over KB. Dalawang layers lang naman yung involved doon. Diba? Substitute natin. Ano yung H? HA plus HB, which is 350 mm plus 350 mm. Divided by HA, 350 mm. Over KA, 2.57 centimeter per minute. Plus HB, 350 mm ulit. Over KB, 3.43 centimeter per minute. Naka-stored values yung mga yan. Cancelled ang millimeters, naka-centimeter per minute ang hydraulic conductivity natin. Ano yung sagot niyo dyan?
.94.
2.94 centimeter per minute. No? Additional question, kumbaga pag naipad na itong, that will be your answer. What if, in this setup, maglalagay pa ako ng piezometer dito sa part ng soil A na yan. Pag may piezometer tayo dyan, there will be a pressure head. No, lalabas yung tubig dyan or magfo-flow pataas due to the pressure of water. No, until up to that point. Tama? Eh ngayon, ipapakompute sa atin yung head loss dyan. So how can you compute the head loss? No, you can, sabi nga, vertical flow condition. Diba? Pag vertical flow condition, alam nyo na yung formula. Alam nyo na yung principle. That flow rate is equivalent to flow rate. No? Eh yung cross-sectional area, pare-parehas yan all throughout the flow. Tama? So, pag pare-parehas yung area, magiging discharge velocity equivalent to discharge velocity. Ang discharge velocity, Ki. Tama? Eh ngayon, kapag i-consider natin mismo yung tatlong pipe na to or tatlong piezometer na to that is attached kay soil A, nakatouch silang lahat kay soil A, di ba? Ibig sabihin, yung hydraulic conductivity ay iisang lupa, yung ina-analyze. Kapag ina-analyze mo yung head loss between these two piezometer at yung head loss between this piezometer and this piezometer, iisang lupa lang yung ating kinonsider. That is why hydraulic conductivity ay parehas lang. So sa formula dito or equation dito, cancelled na. You can say that hydraulic gradient is equivalent to hydraulic gradient. Ano bang hydraulic gradient? H over L. Equivalent to H over L. Tapos dyan sa equation parang nagre-ratio and proportion lang tayo. Nasaan yung ratio and proportion natin doon? Kasi nga, according to hydraulics natin, pwede nating i-drawing yung energy gradient line. No? Ginawa nyo na yan. Nag-drawing kayo ng energy or total energy gradient line, ng hydraulic gradient line. No? Nasaan yung ating gradient line? From this point to this point. It involves linearity. No? Between this line. Ngayon, meron tayong triangle na mafo-form. No? With respect to the triangle, you can use ratio and proportion para ma-solve nyo yung head losses natin. No? So, parang nagre-ratio and proportion pa rin kayo. Ngayon, tatanungin nyo, Sir, paano naman kay soil B? Itutuloy ba natin tong linyang ito hanggang sa makarating kayo doon? No. Yung slope ng gradient line, dito sa part na to, papunta sa part na to yun, magkaiba sa slope ng head loss kay soil B. No, bakit magkaibang soil layer na yan? Pero kung yung soil A, tuloy-tuloy hanggang dito, iisang hydraulic gradient yon or iisang hydraulic conductivity yon, tuloy-tuloy lang yung ating gradient line yan. No, with the same slope, pero hindi. No, ano ang gagawin nyo? Ibig sabihin nun, hindi magka-cancel yung hydraulic conductivity natin doon. no, magiging KI equivalent kay KI. No, KI ni A, KI ni soil layer B. No, yun yung ating principle na gagamitin doon. Pero, pwede ka pa rin mag-straight line dyan. No, linear yan. Pero iba yung slope dito sa slope dito. No, meron ako na mga na-present na problems regarding this. Yung una pala. So, study that. Okay, so, let's have another one. We have here a compacted clay specimen of 101.6 millimeters diameter and 116.4 millimeters height is subjected to a falling head permeability test. The inner diameter of the standpipe is 3 millimeters. When the test started, the head difference was 1050 mm, which dropped to 835 millimeter after 20 minutes. Determine the hydraulic conductivity of the specimen. If the same soil specimen is subjected to a constant head permeability test under a head difference of 600 mm, how much water will you collect in 20 minutes? Meron dalawang method na nabanggit. Let's list down yung mga parameters involved in each test. Under falling head test, meron tayong soil sample having a diameter of 101.6 millimeters. Meron siyang height, which is 116.4 mm. With that data, malalaman na natin na cylindrical yung soil sample. Tama? The inner diameter of pipe is also given, 3 millimeters. And then initial head difference, when time equivalent to 0, or when the test started, that is 1050. And then it was dropped to H2, final head difference, 835 millimeters. No? And then the duration of the falling head test is 20 minutes. And then pinapakompute yung hydraulic conductivity ng soil specimen. A falling head test, no, ano ba yung formula? That is AL over 80, ln of H1 over H2. No? O direct substitution. Ano yung A? Cross-sectional area ng standpipe. May diameter, kaya circular yun, pi over 4. Diameter of 3 millimeters, quantity squared. What is L? Length of flow. Mapapansin nyo, walang L na binigay. No? Pero, ang direction ng flow, perpendicular sa cross-section. Nasa ba yung cross-section? Eto, di ba? So, nandyan mismo yung direction of flow. O kaya pataas. No, wala kasing binigay na flow, pababa or pataas. Pero since it's falling head test, pababa yan. No? So, kapag nandito yung cross-section, nandito yung height. And that height is parallel to the direction of flow. Kaya yung magiging L natin. So, substitute natin, that is 116.4 millimeters. Over cross-sectional area of the soil. Diameter yung binigay, kaya pi over 4. 101.6 millimeters quantity squared. Multiplied by duration, 20 minutes. Multiplied by ln of initial head difference, 1050 over final head difference. Cancelled ang mm and then millimeter per minutes. What is hydraulic conductivity?
.163 times 10 to the negative 3.
Okay, that is correct. Millimeter per minute. No? Store natin kay A. Ngayon, paano daw kapag nag-conduct tayo ng constant head test? Anong mangyayari daw? So, sabi doon, the same soil specimen is subjected to that constant head test. Ibig sabihin, kung ano yung parameter ng soil dito, yung diameter tsaka height, yun din mismo yung gagamitin natin kay constant head test. Kasi nga, the same soil sample. And, kung ano yung hydraulic conductivity ng soil specimen na yan, yun din gagamitin natin na value for hydraulic conductivity in this constant head test. Siyempre, hindi magbabago yung hydraulic conductivity kasi nga the same soil. Iba lang yung test. No? Kahit na magkaibang test yung gamitin nyo, the same hydraulic conductivity value yung mako-compute. No? So, ano binigay dito? Meron tayong constant head difference na 600 millimeters and then duration of 20 minutes. So, pag constant head test, dapat alam nyo yung equation. Ano hydraulic conductivity? Sabi natin that is 1.163 times 10 raised to 3 or negative 3 millimeter per minute. And then equivalent to volume, yan yung kino-compute. No, ano daw yung amount of water? And then length of flow, yung height, 116.4. Cross-sectional area, pi over 4, 101.6 mm, quantity squared. Constant head difference, 600. Ang duration natin, same as 20 minutes. So, analyze yung unit. Cancel to. Cancel yung minutes. Mm squared times mm, magiging mm cube, which is a unit of volume. Ano po yung Q natin?
$971.706.
Okay, that is millimeters cube. No? And that will be your answer for this problem. Same answers po?
Yes po,
Yes
sir.
po, sir.
Okay. Let's proceed with the next one. Ito. Ang dali din to, kaya lang medyo i-analyze lang yung figure. A 500-meter long levee made of compacted clay impounds water in a reservoir as shown below. There is a 1-meter thick sand seam continuing along the entire length of the levee at 10 degrees inclination with respect to the horizontal, which connects the reservoir and the ditch. The hydraulic conductivity of the sand is 2.6 times 10 raised to negative 3 centimeter per seconds. Determine the volume of water that flows into the ditch every day. So, analyze natin yung mga binigay na parameters. Meron daw tayong 500 meters na length ng levee. Yung length, hindi natin nakikita dito kasi nga 2-dimensional yung figure. Pero kapag gagawin natin 3-dimensional, nandyan yung length. Ito ay 500 meters. No? So, assume nyo na lang na nandun yung 500 meters, which is perpendicular to this figure. Kaya hindi natin nakikita. And there is a 1 meter thick of the sand seam. Ito yung sand seam natin. This is 1 meter. Yung thickness. No? Kapag meron tayong thickness dyan, paano ba magfo-flow? Saan ba nag-start yung flow? From the reservoir, di ba? Papuntang ditch. Bakit? Mas mataas yung energy head sa reservoir compared dun sa ditch. So the water will flow from the reservoir papuntang ditch. Pero kapag nandito yung water kay ditch, sabihin natin, ditch mag-uumpisa yung flow papunta kay reservoir. Pataas. No? Pero hindi yung case. So paano magpo-flow? Gawin lang natin. Ganyan, no? Yung direction of flow natin. At yung direction of flow is perpendicular to the cross-section. No, etong 1 meter na to perpendicular sa direction of flow. Para maging cross-sectional area, i-multiply natin yung length, which is 500 meters. So cross-sectional area is 500 square meters. No? Now, kung yan yung direction of flow, nasan yung length? It should be parallel to the direction of flow. Nandito yung length, di ba? Hindi pa binigay. Dahil ang binigay dito, horizontal distance between the reservoir and the ditch. Pero, yung sand seam merong inclination. With respect to the horizontal, 10 degrees. So, we can use trigonometric functions of right triangles. May angle, may adjacent side, may hypotenuse. Cosine function. Cosine of 10 equivalent to 200 divided by the length. What is the length of flow?
203.085.
0.85 meters. Store the value as A para hindi tayo nag-round off. You have now the length of flow. And then, ano pang binigay? Meron tayong hydraulic conductivity, 2.6 times 10 raised to negative 3 centimeter per seconds. Hydraulic conductivity ng sand, yung buhangin. Kasi pag sand, merong flow. Yung levee, made of clay. Pag clay, may pagka aquiclude. No? Po pwedeng mag-sip yung tubig, pero mabagal. And then, pag minsan di na makakapunta kay beach, no, tutuloy lang din, pupunta lang din kay sand seam. No? So walang flow dun sa levee, nandun kay sand seam kasi siya yung sand layer. And then yung requirement is to determine the volume of water collected, yung Q, no, or V. Tama? In a duration of 1 day. Every day daw or per day. No? So anong gagawin nyo dyan? And kung i-analyze natin yung figure natin, you have an elevation here, high energy and then low energy. No? If we are going to take the difference between the high energy and the low energy, that will be the value of head loss. No? High energy and low energy na nakakabit sa magkabilang dulo ng layer ng soil natin. No? So that is elevation 38 minus elevation 28, 10 meters ang head loss. No? So with that, paano natin mako-compute yung volume? Sabi natin, flow rate is volume over time. Diba? Ang dimension ng flow rate is L cube over T. So that is volume over time. But flow rate is also equivalent to the product of cross-sectional area and discharge velocity. Yung discharge velocity, that is a product of hydraulic conductivity and hydraulic gradient. Yung hydraulic gradient, ratio yun ng head loss with respect to the length. Ito na yung gagamitin yung equation. Kung isi-simplify nyo yung equation na yan, parang equation ni constant head test. No? Magiging QL over AHT, yung K. No? So, pwedeng yung gamitin rin yun. So, substituting, volume is unknown. Ang time natin ay 1 day. Cross-sectional area is 500 square meters. Hydraulic conductivity is 2.6 times 10 raised to negative 3 centimeter per seconds. The head loss is 10 meters. Divided by the length, ang length natin ay 203.085 meters. Naka-store value. Analyze the units. Ito, canceled. Naka-seconds yun, day. Convert natin. 1 day is to 24 hours. 1 hour is 60 minutes. 1 minute is 60 seconds. Canceled yun. Canceled ang seconds. Square meters times centimeter, hindi siya consistent. Gawin natin siyang cubic meters. So, 1 meter is to 100 centimeters. Cancelled ang cm, magiging cubic meters na yung unit ng volume natin. Paki-compute po.
$55.307.
How about the others? I think this is correct. Kindly confirm.
Same lang po, sir.
Okay, no? So, madali lang siya. Papansin direct substitution. No? Ang mahirap lang yung pag-analyze ng bawat parameters. No? Pag nag-iba na yung figure, mag-iba rin yung analysis. No? Kaya intindihin nyo yung problem tsaka yung figure. Okay, let's have another one. We have here a site consists of a homogeneous dense silty sand layer of 10-meter thickness, which is underlain by an impervious stiff clay stratum. The initial water table was at 3.0 meter depth below the ground level. A pumping test was carried out by pumping out water at the rate of 0.5 cubic meter per minute. observation wells were dug into the ground at 20-meter and 30-meter distances from the center line of the well. The steady state, when the water levels in the two wells dropped by 500 millimeter and 150 millimeter respectively, determine the hydraulic conductivity of the clay sand layer. So nabanggit yan yung pumping of wells. When we say pumping of wells, that is a field test of hydraulic conductivity. Pag sinabing field test, dalawang condition. It's either confined aquifer or unconfined aquifer. Ngayon, nasa ang condition tayo? Walang figure ng binigay. Di ba? So, kailangan natin i-drawing para malaman natin kung nasa ang condition. No? Ano sabi dito? We have a silty sand layer is underlain by a stiff clay stratum or a clay layer. So, meron tayong dalawang layers na binanggit. Ang tanong ngayon, ano yung nasa itaas, ano yung nasa ilalim? No? Dahil kapag nagkabaliktad yung dalawa, mag-iiba yung condition. Ay analyze natin. When we say silty sand layer is underlain by a clay layer, ang nasa itaas ay yung sand. Ang nasa ilalim ay yung clay. Pero, kapag sinabi dyan na silty sand layer is underlain to clay layer, magkakabaliktad yan. Again na, nag-iba lang yung by at saka to. When we say sandy or sand layer is underlain to clay layer, clay ang nasa itaas, sand ang nasa ilalim. Paano naman kapag sinabing silty sand layer is overlain by clay layer? Kapag ganun yung ating sentence, clay ang nasa taas, sand ang nasa ilalim. Paano kapag sinabing silty sand layer is overlain to clay layer? Ganito yung setup nun. Silty sand layer is overlain to clay layer, sand ang nasa itaas, clay ang nasa ilalim. No? Kaya iintindihin nyo mabuti kung ano yung sinasabi ng problem. No? Pag sinabing sand, that is considered as aquifer. Pag sinabing clay, that is considered as aquiclude. No? Ngayon, ito yung setup. Nasa itaas yung aquifer. Na kapag yung aquifer ay nasa pinakaitaas na layer, that is considered as unconfined aquifer. Alam na natin condition. Unconfined. Ngayon, anong ginawa dito? Pumping of wells or pumping test. Meron tayong test well, meron tayong dalawang observation well. No? Anong sabi doon? We have a 10-meter thick aquifer or sand layer. No? And then, the initial water table, assume natin nandito, hindi natin alam. Pero, yung depth, with respect to the natural grade line, that is 3 meters. Nandiyan yung tubig natin or water table. And then, a pumping test was carried out. No, and then, nakapag-pump out tayo ng tubig having a flow rate of equivalent to 0.5 cubic meters per minute. No? And then, merong distances yung dalawang observation well with respect to the center line of the test well. Usually, with respect tayo talaga sa center line ng test well. No? Kahit hindi sinabi. Yung mas malayo daw ay 30 meters. Yung mas malapit ay 20 meters. No? Kapag nag-pump tayo, there will be a drawdown. Bababa yung level ng tubig doon sa test well at saka observation wells. No, initially nandyan. Ayun, nag-pump out, bababa. Assume natin na nandito na. No? Kapag bumaba yung level ng tubig sa test well, apektado rin yung level ng tubig doon sa observation wells. No? Ganyan daw yung figure natin. No, nandito na yung level ng tubig doon, yung level ng tubig. And then binigay yung drawdowns doon sa observation wells nating dalawa. 500 mm and 150 mm. Siyempre, yung mas malapit sa test well, mas malaki yung drawdown. Yung mas malayo sa test well, mas maliit yung drawdown. So, itong drawdown na to ay 500. Yung drawdown na to ay 150. This is Z2. And then this is Z1. Ito naman si R1. Ito naman si R2. No, ano yung R1? Ano yung R? Distances ng observation well from the center line of the test well. Pag sinabi nating 1, yung parameter ng mas malayo. Pag sinabi nating 2, parameter ng mas malapit. Ano yung Z? Drawdown in the observation well. Pag sinabing 1, parameter ng mas malayo. Pag sinabing 2, parameter ng mas malapit. No? So pag meron tayong drawdown dyan, mako-compute natin yung level ng tubig in the observation wells. Yung H1 tsaka H2. No? How can we compute H1? Papansin nyo dyan, kung 10 meters to, 3 meters to, this will become 7 meter. And that 7 meter is from this point to this point. From this point to this point. Diba? So we can say that H1 is 7 meters minus 150 mm, or that is 0.15 meters. So with that, H1 will become 6.85 meters. And then H2, that is 7 meters minus the drawdown. Z2, that is 500 mm, or that is 0.5 meters. So H2 is 6.5 meters. So, meron na tayong mga parameters. Ano ba yung equation ng hydraulic conductivity for unconfined? That is K equivalent to Q ln of R1 over R2 multiplied by or divided by pi multiplied by H1 squared minus H2 squared. So substitution na lang yung mangyayari. No? Hydraulic conductivity is Q, the flow rate, which is 0.5 cubic meters per minute. Ln of quantity R1, which is 30 meters, over R2, which is 20 meters. Over pi, multiplied by quantity H1 squared, that is 6.85 meters quantity squared, minus H2, 6.5 meters quantity squared. So, analyze natin unit. Cancel dyan. Magiging meter per minute tayo. So, ano yung ating hydraulic conductivity? Kindly compute.
0.0138.
0138, that is meter per minute. How about the others? Parehas po ba?
Same lang po.
Okay. So, that will be the requirement of this problem. No? So, analysis lang para may drawing nyo ng maayos. Pag minsan naman, binibigay na yung figure. No? Pero kadalasan hindi. So, you should analyze. No? Let's have another one. We have here a pumping well of 25 centimeter diameter was fully penetrated into a 20-meter thick bed of sand, which lies between two clay layers of negligible permeability. Laboratory tests revealed that the sand had a coefficient of permeability of 0.03 centimeter per second. A steady state was reached when the drawdown in the test well was 4.3 meters, and the corresponding discharge or flow rate was 12 liters per second. Estimate the drawdown in the observation well or in an observation well sunk at a distance of 20 meters from the pumping well. Calculate the radius of influence. Compute the transmissibility of the sand. Okay. Again, walang binigay na figure. Analyze natin. Meron tatlong layers na binigay, di ba? Let's draw. Anong sabi sa problem? Meron daw tayo sand layer. No, that sand layer is 20 meter thick. Ito yon. And Yung sand layer lies between two clay layers. So, napagitnaan daw siya ng dalawang clay. Again, sand is an aquifer, clay is an aquiclude. From that figure alone, alam na natin yung condition. That is under confined aquifer condition. No? So, meron daw tayong pumping well. So, assume natin nandito yung pumping well or yung test well natin. The test well has a diameter of 25 centimeters. No? And then, laboratory tests revealed that the sand has a coefficient of permeability. Meron na tayong K. Hydraulic conductivity 0.03 centimeter per seconds. Steady state was reached when the drawdown in the test well was 4.3 meters. Kakaroon daw ng drawdown. Ngayon, hindi natin alam kung nasan yung water table. No? Po pwede mong ilagay nandito yung water table, po pwedeng nandito, po pwedeng nandyan, kahit saan. No? Huwag lang dito. No? Pag nandyan, edi medyo mahirapan tayo mag-solve. No? Within this length or depth of test well dapat. Assume natin nandito na yung water table para walang masyadong linya. No? Pero kahit nasaan yan, okay lang. No? Dahil wala namang sinabi kung anong depth ng water table natin. Now, kung nandiyan yung water table natin, initially, magkakaroon daw ng drawdown yung test well natin. No? Nandito na yung level. At yung drawdown dito, that is 4.3 meters. No? And the corresponding discharge, we have a flow rate. Discharge is 12 liters per second. So mamaya na natin siya i-convert, no, para maging consistent yung units. The requirement is to estimate the drawdown in an observation well. Meron daw tayong observation well. Yung mas manipis. And then sunk at a distance of 20 meters from the pumping well. Pag sinabing from the pumping well, with respect sa center line palagi. No? At hindi sinasabi. This is 20 meters. Ngayon, magkakaroon din ng drawdown doon. Maapektuhan siya. No? Ang pinapa-compute, ano daw yung drawdown dito? What is that Z? Assume natin Z1 yun kasi mas malayo siya center line ng test well. Etong drawdown dito, sa gilid ng test well, that will be your Z2. Kasi nga, mas malapit yung drawdown na yan sa test well kasi nandun sa test well. No? Etong 20 meters, that is R1 kasi mas malayo yan sa test well. How about yung R2? Ito yung R2 natin. No? Kung nasan yung drawdown, nandun din yung R2. No? So R2 is the radius of the test well, which is kalahati ng 12.5 cm. In meters, that is 0.125 meters. No? Conversion of units. Now, eto na yung H1. This is H1. If this is Z2, from this point to this point, this is H2. Tama? Anong gagawin natin? Confined aquifer. Ano ba yung formula ng confined aquifer? Hydraulic conductivity is equivalent to Q, ln of R1 over R2 divided by 2 pi multiplied by the thickness of the aquifer multiplied by H1 minus H2. Let's compute first H1 and H2. No? H1 is, papansin dyan, Z1 plus H1 is the thickness. No? Kahit hindi naman gamitin yung thickness, okay lang. Kasi nga in-assume lang naman natin nandun yung water table. Pwedeng i-assume na nandito. No? And that is okay. Hindi magiging H yun. No? Para makompute yung H1 tsaka H2. And that is okay. Parehas pa rin yung makocompute nating sagot. Okay, now H1 is 20 meters minus Z1. No? Ang H2, that is 20 meters minus Z2, which is 4.3 meters. E ang kailangan natin later on, H1 minus H2. No, ima-minus na natin. What is H1 minus H2? 20 meters minus 20 meters, 0. negative Z1 minus negative 4.3. That is 4.3 minus Z1. Ay sabi ko kanina, kahit nasan yung water table, okay lang. Kasi magka-cancel lang din naman yun. No? Kahit saan nyo ilagay. Dahil kapag minus natin H1 tsaka H2, it involves only the difference of the drawdown. No? So with that, let's compute the unknown, which is Z1. Ang hydraulic conductivity is 0.03 centimeter per seconds. Ang flow rate ay 12 liters per second. No, convert na natin. That is 1 cubic meter is to 1,000 liters. Para hindi na tayo mako-convert later on. Multiplied by load of R1 over R2. Ang R1 ay 20, ang R2 ay 0.125. 20 meters divided by 0.125 meters. Divided by 2 pi. Ang thickness ng aquifer, yung thickness ng sand, no, yung kapal lang ng aquifer, 20 meters. Multiplied by H1 minus H2, that is 4.3 meters minus Z1. No? So, analyze natin, this is meter. Convert natin yung, etong seconds cancelled na. Convert natin centimeters into meters. 100 cm is to 1 meter. Cancelled na yon. So, okay na, no? Z1 will be in meters. Ano po yung Z1 natin? Z1 or yung drawdown sa observation well should be less than the drawdown in the test well. Kasi ganyan, no? Papansin, mas maliit talaga yun kaysa kay 4.3. Pag mas malaki kay 4.3 yung na-compute, mali yung computation. So, what is Z1?
$2.68.
2.68 meters. How about the others?
Same lang po.
Okay, same lang. Store natin kay A. Hindi tayo nag-round off. No? Now, meron pa tayong requirement. We have to calculate the radius of influence. Ano yung radius of influence? Hanggang saan aabot yung drawdown? From the center line of the test well. Ito yung drawdown natin, no? Hanggang dito daw. So, ang radius of influence, ito. Hanggang sa point na yun. Ano yung radius of influence na yan? No? So, that radius of influence should be greater than 20 meters. Dahil mas malayo itong point na to doon sa point of application ng observation well. So, with that, meron tayong formula for that. No? That radius of influence is 3,000 multiplied by Z square root of K. Ano itong K? Hydraulic conductivity ng aquifer. Ano yung Z? Drawdown sa test well. Take note, Z, drawdown sa test well. K, hydraulic conductivity. So, substitute. That will be 3,000. Ano yung Z? Drawdown sa test well. Ito yun. Yung drawdown dito sa test well, itong malaking pipe na to. That is 4.3 meters. 4.3 meters. Square root of hydraulic conductivity. Ang radius, naka-meters dapat. Yung drawdown, naka-meters dapat. Yung ating hydraulic conductivity, it should be in meter per seconds. Bago natin i-substitute. Ang hydraulic conductivity, naka-centimeter per seconds. Convert lang natin into meter per seconds. Diba? So that is, dito na lang natin ilagay. So this is 0.03 centimeter per seconds. Kailan doon naka-meter per seconds? So that is 100 cm is to 1 meter. Cancelled, cancelled. What is radius of influence? Kindly compute.
223.43
meters. No? Questions? That is radius of influence. Next one, we have to compute the transmissibility of the sand. Transmissivity or transmissibility. That is T. No? Meron tayong formula for that. The formula of transmissibility of the sand, that is Q ln of R1 over R2 over 2 pi multiplied by H1 minus H2. Papansin nyo, parang hydraulic conductivity lang, di ba? Yung hydraulic conductivity ng confined aquifer, merong thickness lang dyan. No? Nag-cancel lang yung thickness. Bakit? Ang transmissibility or transmissivity, that is hydraulic conductivity multiplied by the thickness of aquifer. No? Yung ating equation for that. E ngayon, kung yung hydraulic conductivity may T dito, imumultiply mo ng T para makompute yung transmissibility, canceled na. Diba? So, yun yung ating equation. Okay, so either of these two, okay lang gamitin nyo for this kind of problem. No? Or for this condition. Meron tayong hydraulic conductivity, na-compute nyo na, or binigay. You have the thickness also. So, you can now compute transmissibility. Therefore, T is equivalent to, ang K natin ay 0.03 cm per seconds. Ang thickness natin ay, ang thickness, 20 meters. 20 meters. So, convert natin yung units. 100 cm is to 1 meter. Cancel dyan. Ano po yung value natin?
0.006.
Dalawa? Ganyan ba?
Opo.
Okay. Mapapansin nyo, yung unit dyan is square meter per seconds. No? Yan yung na-compute natin. Pero ang transmissibility, that is the flow rate per unit width. No? Pag sinabing flow rate, naka-cubic meter per seconds per unit width. So, dapat ganyan. Kapag cubic meter per meter, square meter yan. Pero dapat nakaganyan yung unit daw. So, cubic meter per seconds per unit. That is transmissibility. Okay lang naman square meter per seconds. No? Bibigyan ko na kumbaga. Questions?
Wala naman.
Wala naman. Okay, so let's proceed with the next one. Okay, ito. No? The figure shows a soil profile at a given site. And we are required to determine, first one, average coefficient of permeability of the deposit. Number two, equivalent coefficient of permeability in the deposit in the horizontal and vertical direction. Meron tayong 4 na layers na binigay. Walang binigay na flow. Kaya pinakompute na yung dalawang condition, horizontal tsaka vertical flow. Pero kapag merong binigay na flow dyan, i-analyze mo kung nasang condition. No? So, first one, average. Pag sinabing average, alam nyo na, total divided by the number of layers. So, average hydraulic conductivity, isa-sum up nyo lang. No, summation of K divided by the number of layer. No? So, summation ng ating hydraulic conductivity, parang ano lang, mean, no? Pag-compute ng mean or average, alam nyo na yan. This is 3 times 10 raised to negative 4 plus 2.5 times 10 raised to negative 8 plus 8 times 10 raised to negative 3 plus 7.2 times 10 raised to negative 2 divided by ilang layers? 4. No? Regardless of the thickness, that is average. Ano po yung average natin? 0.02, that is in centimeter per seconds. How about the others?
Same lang po.
Same lang
Okay.
po.
Now, let's proceed with the second requirement. No, ito na yung topic natin, equivalent. No, equivalent hydraulic conductivity in horizontal and vertical. So, alam nyo na yung formula. No, horizontal muna, KHEQ. That is K1H1 plus K2H2 and so on. Apat yan, divided by H. No, so that will be equivalent to K1, 3 times 10 raised to negative 4 times H1, 8 plus 2.5 times 10 raised to negative 8 times H1 plus 8 times 10 raised to negative 3 times 6 plus 7.2 times 10 raised to negative 2 times a thickness of 10 divided by the total H. Ano yung total H natin? 25 meters. So what is KHEQ?
.03.
Centimeter per seconds. How about the others?
Same lang po.
Same lang po.
Okay. And then vertical, dali lang din yung formula. KVEQ. And that will be equivalent to total 25 meters over H1 over K1. 8 over 3 times 10 raised to negative 4 plus 1 over 2.5 times 10 raised to negative 8 plus 6 over 8 times 10 raised to negative 3 plus 10 divided by 7.2 times 10 raised to negative 2. No? So what is KVEQ?
.25 times 10 raised to negative 7.
Okay. How about the others? Kindly confirm.
Same lang po.
Same po, sir.
Okay. Questions? May questions po tayo sa discussion?
Wala pa naman po.
Wala pa naman. Okay. Eh, yung iba? Baka may mga katanungan yung iba.